Okay, everybody, this is the video of me going over every one of the homework problems from last night. You can skip ahead and go to the ones that you are pretty sure you don't know how to do. You can just check your answers as you go, but obviously make sure you're getting them right for the next homework quiz. This is from this worksheet right here, 3.4 worksheet, and I just hand wrote them out so I can write them out a little bit bigger. All right, so let's start with number 1. I would get these to be the same base. So 5 to the x equals 125 is 5 cubed, and then multiply that by x minus 2. So x equals 3x minus 6, which is negative 2x equals negative 6, so x equals 3. All right, this one with a bunch of logs. I think I'm going to switch pens. If it has a bunch of logs, remember, you want to condense one side, this side, and then keep it equal to 1 log. So let's condense. When I add 2 logs, I actually write it as 1 log where these two are multiplied. Now I'm going to put the 9 in front, so 9x equals log base 6 of 54. And now, once you have 2 logs that are equal to each other, you can just set these two equal to each other. 9x equals 54. Whoops. So x is 6. Okay, number 3, I'd get these to be the same base. So this is really 3 squared. Since it's a fraction, I'd write it as 3 to the negative 2, and then times the x plus 3 exponent. This is 3 to the 3rd, and then times the x, and then set those equal to each other. So negative 2x minus 6 equals 3x. And then you get, negative 6 equals 5x. And divide by 5. So x equals negative 6 fifths. All right, these E ones. This was something I went over with you. This should have been an easier one. So when I see e to the 2x and I see e to the x is my u, which means u squared would be e to the x squared or e to the 2x. So I'm going to actually call this u squared. This is u, and then minus 6. And that is just something that we've done in the past. With Miss Davis, you did a bunch of these. This is factoring. So what 2 numbers multiply to a negative 6 but make a negative 1 when you add them? And the correct answer would be, let's see, u minus 3 and u plus 2. And then what you do is you set each one of these equal to 0, but instead of the u, you replace it with e to the x. So e to the x minus 3 equals 0. E to the x plus 2 equals 0. And so let's see, we get e to the x equals 3. And how do I solve for an e to the x? Well, I take the ln of both sides. Ln and e cancel. So I'm left with x equal to ln of 3, which is a number in your calculator. You can find it out. E to the x equals negative 2. And then I take the ln and e cancel. X equals, can I take the ln of a negative 2? No. Okay. So that is my only answer. X is ln of 3. Okay, number 5, if you see 1 log on one side, you zoop. X to the 3 equals 64. How do you solve if you're cubing x? Cube root. So x equals the cube root of 64, which is 4. So there's the first 5 problems. Let's move on to number 6. The ln of 1 over e equals x. So what I did with this one is I rewrote this as e to the negative 1, because that's what 1 over e is. And hey, look, you have an ln and an e next to each other. They cancel. So x is negative 1. Now I have an ln of 2x minus 1 equals an ln of 16. Well, again, ln's are just logs, just written differently, they're the same as logs. So these two, you can set equal to each other. 2x minus 1 equals 16. 2x equals 17. So x is 17 over 2. Number 8, remember I told you to skip that one. That's like using quadratic formula. I don't want you to do that. I would rather you practice factoring on the other ones. Number 9, again, I see a bunch of ln's. Condense. If you see a bunch of ln's, condense both sides. So if I condense this side with adding, that means I multiply these two. So I have the ln of 4 times x minus 5. On this side, I'm minusing, so I have the ln of this divided by this. So now I have ln and an ln. I can set these two equal, just like I did up here in 7. So 4x minus 20 equals x over 2. I don't like that fraction, so I'm going to get rid of it. So I'm going to multiply everything through by a 2. This by 2, this by 2, this by 2. So 8x minus 40 equals x. And then get all your x's on one side and numbers to the other. So 7x equals 40. X is equal to 40/7. I'm double checking right now that if I put a 40/7 right here, I would remain positive, and here would be fine also. Okay, number 10, 4 and 6. Unfortunately, they cannot become the same base. So I need to ln it or log it. Whatever you did, it's up to you. It doesn't matter. So I'm going to ln because I like ln's. And then you bring this to the front. So x plus 2 times the ln of 4. And you bring that to the front. So negative 2x minus 3 times the ln of 6. And then you got to distribute it. Because remember, ln of 4 is just a number. So x ln 4 plus 2 ln 4. This one would be negative 2x ln 6 minus 3 ln 6. Get all your x's on one side and everything that has a number and an ln to the other. So pretty much you're switching these two. So x ln 4 plus 2x ln 6 equals negative 2 ln 4 minus 3 ln 6. Factor out an x. You get ln 4 plus 2 ln 6. And this side stays the same. And then you divide by that ln 4 plus 2 ln 6. And of course, I'm running out of room. This is full credit right here. But what you would do to like simplify this is, let's see if I can squeeze it in. This becomes the power of 4, and this 3 becomes the power of 6. So the top would be read as ln of 4 to the negative 2 divided by 6 cubed. That's the top. And then you would divide it by, the bottom is an addition. First move that 2 to the 6. So additions means you multiply. So it would be divided by the ln of 4 times 6 squared. And punch that in your calculator, and I will tell you, you should get negative 1.639. Oof, sorry for how squishy that is. But we'll do another one like it. I think there's another problem similar to it. Okay, number 11. So I see 6e to the 6x minus 17e to the 3x plus 7. Trinomial, so we're going to have this u thing. So this is usually your u. This is your u squared, which makes sense if I multiply this by 2. So I'm actually going to call this 6u squared minus 17u plus 7. And you definitely want to make a note here, equals 0, that u is equal to e to the 3x. And then Miss Davis told you what multiplies to 42, but adds to the middle of negative 17. And you got to go through, I think she taught you a trick. I know she taught it to me, but you could always do this. For those who don't know, you put, it multiplies to 42, so you do 42 divided by x, and then you go to your table, and you look at all the numbers that can make, what we're looking for is 17, so 3 and 14, if they're both negative. So I'd say u minus 3 and u minus 14. Those two would multiply to positive 42, but would add to a negative 17. But because this has a 6 in front of it, I have to divide this by 6 and this by 6. And so this reduces to 1/2, but you want to bottom up, so 2u minus 1. And this one reduces to, reduces to 7/3. And so you want to bottom that one up. And then, remember, your u is actually e to the 3x. So you're going to substitute that back in. 2 e to the 3x minus 1, and then set that equal to 0. And then 3 e to the 3x minus 7 equal to 0. And then let's solve this. So 2 e to the 3x equals 1. Divide by 2. E to the 3x equals 1/2. Take the ln of both sides. 3x equals ln of 1/2, and then divide by 3. And so that would be the exact answer. Let's find out what the decimal answer is. The ln of 0.5, and then divide that by 3, negative 0.231. And then same on this side. 3 e to the 3x equals 7. Divide by 3, e to the 3x equals 7/3. ln, once your e is by itself. So ln of 7/3, and then divide by 3. Notice you're not taking the ln of 7/3 divided by 3, you're taking the ln of 7/3. So ln of 7/3, getting that answer, and then dividing it by 3, so 0.282. And that was number 11. And number 12, I've squeezed over here. So got all these numbers in front of an ln, add that 3 over, so you get 6 ln of x plus 2 equal to 24. Divide out the 6. You want your ln by itself. You want your e by itself. You want your ln by itself. All right, and then how do you undo an ln? You e it. Okay, so it's e to this power, e to that power. The e and the ln cancel, and you're left with x plus 2 equals e to the 4th. And then you minus 2. So e to the 4th minus 2, let's see what that is. E to the 4th, and then minus 2 is 52.59, 52.6. That is your answer for number 12. All righty, 13. I gave it its own sheet here. So 13, similar to number 11. So my u is going to be e to the x. So this would be 4u squared minus 13u plus 9 equals 0. Got to figure out what multiplies to 36, but adds to a negative 13. And again, just to show you that trick, Miss Davis did teach it to you. You can put 36 over x and look at the table and see which 9 and 4 add to a 13, so you just got to make them negative. U minus 9, U minus 4. However, there's a 4 right there. Divide by 4, divide by 4. So this becomes 4U minus 9. This becomes U minus 1. But remember, U is e to the x. So this is 4e to the x minus 9. and this is e to the x minus 1. And then set each one of these equal to 0. And then let's solve. So this would be 4e to the x equals 9. Divide by 4. E to the x equals 9/4. Ln it, now that e is by itself. X equals the ln of 9/4. And you can punch that in your calculator and get 0.810, 0.811. This would be e to the x equals 1, ln both sides. X equals the ln of 1. What's the ln of 1, kids? 0. So, okay. Where am I at now? 14. Bunch of logs. Log, log, log. Let's put them together. When I add, I have to multiply 2x plus 1 times x minus 4. So that would be 2x squared minus 7x minus 4. And on this side, I have 2x squared minus 4. So again, they're both logs. Now I can set these two equal to each other. And to be honest with you, those 2x squares would just go away. So I have negative 7x minus 4 equals negative 4. Or negative 7x equal to 0. So x equals 0, which you would think, oh, that's my answer. But if you plug 0 back right here, or even right here, you would end up logging a negative number, which is not allowed. So this has no solution. Okay, number 15, similar to, oh, which problem was it? We did one just like, and I can't find it. Number 10. Can't get these to be the same base, so take the log or ln of both sides. I'm going to ln it. I just like lning because it helps get rid of everything. So the exponent drops. 2x minus 3 is the exponent, and then ln 3. Distribute negative 4x ln 2 plus 1 ln 2 equals 2x ln 3 minus 3 ln 3. Get all your x's to one side. I'm actually going to switch this. I'm going to move these two because I want this to be positive. So I would have 2x ln 3 plus the 4x ln 2. And on this side, I would now have a positive 3 ln 3 plus ln 2. And on this side, I'm going to factor out an x, and I'm left with 2 ln 3 plus 4 ln 2. And then, whoops, I divide out that. So I would get x equals 3 ln 3 plus ln 2 divided by 2 ln 3 plus 4 ln 2. And again, you're going to want to put that in your calculator correctly. So let's say the top would be 3 cubed plus means times. So ln of 3 cubed times 2. And the bottom would be, oh, let's see, plus again. So ln of 3 squared, which is 9, times 2 to the 4th. And that would give you an answer. If you get it right, if you punch it in your calculator, you should get around 0.8026. Okay, number 16, we're getting close. 16, again, bunch of logs, logs everywhere. So there's a plus sign, we got to multiply these. So log, I think this is supposed to be a base 5, of x squared plus 4x equals log base 5 of 12. I can set these two equal to each other. And I'm going to set it equal to 0. And I'm going to factor it. Two numbers that multiply to negative 12, but add to a 4 is a positive 6 and a minus 2. So x can be negative 6 or 2, but check. Can I make x to be negative 6 and not get a negative here? Nope. But 2 is good. So 2 is your only answer. 17, same thing. Multiply these two together, and you would get x squared minus 2x minus 3 equal to 6x squared minus 6. Sorry, there's a log in front. And then obviously you can ignore those logs. So let's get all of our x squareds on one side. So let's see what I would have. I'm going to go to that way. 5x squared plus a 2x, and then add the 3 over would be minus 3. Oh, I love this sheet. It's got such good factoring on it. What multiplies to negative 15 but adds to the middle of 2? So 5 and 3, and we need this to be a positive and this one to be negative. And then because there's a 5 in front, divide, divide. So x plus 1, bottom up, 5x minus 3. So x could equal negative 1 or 3/5. Okay, but we got to check. So if I put negative 1, I can see right here, I'm going to still be a negative, so that won't work. And if I put 3/5 right there, 3/5 minus 3 is also going to remain negative, so no solution. So sad. Okay. 18, 19, 20, 25, and 26. Last few right here. All right, the ln of 0.04x equal to negative 8. Okay, to undo an ln, we e it. The e and the ln cancel. You're left with 0.04x equals to the e of negative 8, and then divide by 0.04. So the e of negative 8, and then divide that by 0.04, and you get 0.008. Okay, and then 19 and 20, I'm just going to set you up and tell you what the answer is, but again, depending on if you logged or ln, but you would just, for me, I would just ln 9x ln 2 equals ln of 1210, and then divide by the 9 and the ln 2. So x equals, and again, you can write ln of 1210 over ln of 2 to the 9th, and you should get 1.14. And then the same thing here for 20. The extra step is just minus the 2 over 3x minus 8 equals 36. I like to ln, so x minus 8 ln 3 equals ln 36. And just to show you actually on this one, you could divide out the ln 3 right now, and you'd be left with x minus 8 equals the ln of 36 divided by the ln of 3, and then add the 8 to that number. So x equals ln 36, divide ln 3, and then add an 8. In the calculator, it would look like this. ln 36, divide ln 3, then add 8 to that, and you get 11.26. Okay, last two, 25 and 26. So I have the word problem right here. Miss Cubatz invested a sum of money into a certificate of deposit that earns 8% interest compounded continuously. The formula for calculating interest compounded continuously is A equals PE to the RT. If she made an investment on January 1st of 2005 and the account was worth $12,000 on January 1st, 2009, what was the original amount in the account? Okay, so in 2009, it was $12,000. What was she originally putting in? So $12,000 is what the amount had accrued, the A. P is what we are figuring. E is a number in your calculator. Your R is 8% or 0.08. And the time for which she did that was an elapsed of 4 years. So get out what e to the point, let's see, e to the 0.08 times 4 is, which is 1.377. So we are going to divide 12,000 by 1.37713. I'm going to go a little bit more accurate. 12,000 divided by that. And I get $8,713.79. All right, and the last one, if $500 is deposited into a savings account providing an annual interest rate of 5.6% compounded quarterly, how long will it take for the account to be worth $750? So that's this formula. A equals P times 1 plus R over N to the NT. So 750 is what we want it to be worth. So that's our A. We put in 500. The 1 stays 1. The rate at which we put it in was 5.6% or 0.056 compounded quarterly to the 4 to the NT. So we are solving for T. Ooh, told you we'd get there. All right, so let me explain how to do this. See this 500 here? We can actually divide it over here. So we're going to do 750 divided by 500 and get 1.5. And see this right here? You can actually get this number. Let me get my highlighter here. That's a number in your calculator. It's 1 plus 0.056 divided by 4, which is 1.014. So 1.014 to the 4t. Now, how do we undo that? Well, we ln it or log it. Again, I like to ln. So I got to move over here because I'm running out of room. So again, that 4t will drop to the front. 4t ln of 1.014 equals the ln of 1.5. And then just divide by 4 and the ln of 1.014. ln of 1.014. And let's see what we get left over. So the ln of 1.5 divided by, I'm going to put an extra set of parentheses, 4 ln 1.014. Close it, 7.29. 7.29 years it'll take. All right. Hope you got all the problems you needed for the next homework quiz. Bye-bye.